This question is given in GATE 96. They are saying the same thing. One is, three processes are there and three resources are there, and this is the current allocation, which means at this point of time, this is what has happened. Each process got allocated with this many resources, and now this is the maximum need. So here, instead of giving the future requests, future need, they are saying the maximum need. Maximum need will even include what is allocated, current allocated. So always write the future need. So I'm talking about the future need. If maximum requirement is that and if current allocation is this, then what is the future need? Maximum request is 412 and currently allocated is 102. Therefore, what is the future need? It is 310, isn't it? 412 minus 102, which is nothing but 310, right? And what about next one? The maximum requirement is 151 and the current allocation is 031. Then what is the future need? Future need will be 1 and 2 and 0, right? And what about this one? Maximum need is 123 and the current allocation is 102. Then what is the future need? 0 to 1, isn't it? So this is the future need. Fine. Now using the available, which is 0, 2 to 0, this is the available which they have given. Now they are saying that whether the state is safe or not. They are asking that first. So let's see whether this one is safe or not. So using 2 to 0, can you satisfy any of these needs? I think you could satisfy. You cannot satisfy P0, and you could satisfy P1 and you could satisfy P2. You can, oh no, P2 cannot be satisfied because it is 1. You can satisfy only P1. Now if you satisfy the need of P1 by allocating the whatever it requires from here, then it is again going to give it back, so you need not change it. Now just see what is it going to release, which it is already holding. So it is already holding 031. Therefore they will get released and they will get added to the pool of available resources. Then what do I get here? It is 2. The pool of available resources now will become 2 here, 5 here and 1 here, right? And now after this is done, 251 is done. Using this 251, whose request can be satisfied? Already P1 is over, right? And now let's see if anything I could satisfy. So P0, yes, I could satisfy, and P2, yes, I could satisfy. I could satisfy both of them. So let me satisfy. Oh, P0 I cannot satisfy. P0 is having 3, but here it is 2. P0 cannot be satisfied. I can satisfy P2. If I satisfy P2 using these resources, I have to allocate some of these resources to this, and again it is going to give me back, right? Therefore I am not going to add it, and because of after satisfying P2, P2 will completely execute and it is going to release these resources. What is that is going to release? 102. 102 will get released, and now the new pool of available resources will become 3, 5 and 3, isn't it? Okay, now from here we're using 3, 5 and 3. What can I satisfy? I can directly satisfy P0 now. So finally I can satisfy P0, right? So all the processes are satisfied in some order. I don't care which order. There is one order in which I can satisfy all the processes, and therefore this is the safe sequence. The safe sequence is P1, P2 and P0, right? And here it is only one safe sequence is possible. Other than this, I don't think that you could satisfy them in any other order. You just examine it. I got this, and one safe sequence is enough to say that the state is safe. So the state as of now is safe. There is no possibility of deadlock, right? Yes, there is a possibility of deadlock, but then there is a possibility of not having the deadlock as well, right? Okay, that statement requires some thought. So I don't want you to think so much. What I mean to say is, even if a state is safe, still you could come up with some combinations of allocations that there will be a deadlock. Even if a state is safe, still there is a combination of allocations using which the state can go to deadlock. But then there will be at least one combination of allocations because of which there will be no deadlock. That is what is called safe. Safe means there will be one way in which you could assign the resources to the process and still not have a deadlock. But then you can find out some combinations of allocations because of which there could be deadlock. Understanding this? So safe doesn't mean that there will be no deadlock at all whatever way you go. Safe just says that if you follow at least this order, one order, there will be no deadlock. That is what is safe, right? So definitely it is safe. And now, okay, if you didn't understand the previous point, just forget it, leave it. Let's do this. Now I'm talking about the this request. So the operating system is saying that if I use this request, this one, if I allocate this request, whether this state is going to be safe or not, or the question is, will this request be granted according to the Banker's algorithm? So how can you solve it? Just act as if we are going to grant the request, and then let's see what happens, whether this resulting state is safe or not. Now what is the request? P0 requires 0, 1, 0. If I grant it, then what will be the allocations for P0? P0 allocations will become 1, 1, 2, and what will be the need? Maximum need is going to be same, but then future need is going to decrease. And what about the available? Available is going to be decreasing, right? Why? Because you have already allocated 1, therefore the new availability will not be 220, it will be 210. Now using this available and using this future needs, let's see if there is any safe sequence out. If there is no safe sequence, then we are not going to allocate it. If there is safe sequence, we are going to go ahead with that. Let's see. Now availability is 210. Using this, can you satisfy any of these needs? You cannot satisfy P0 definitely because it requires 3, and you cannot satisfy P1 because we have, it needs two resources, but you have only one resource of type R1, and you cannot satisfy P2 as well because you require 2 resources here and 1 resource here. So after you allocate this, there is no way you can satisfy any of the requests of any of the process, therefore it is unsafe, right? So this request should not be allocated, it should be delayed, which means I don't do it now, and you can allocate other resources which are going to lead you to safe state, and this one you just hold it until the end, right? So this one is not allocated. Fine. So that is about this question. Gate 96 question, you can read about it.